All right, well, here are notes on physical and chemical changes. This is out of our classification of matter section, and it's a little bit out of order, so go ahead and turn to the second page, or third page, if you're thinking front and back, of the classification of matter, and we'll start there. So, what we are going to do, physical change. A physical change is a change that alters only the state or appearance of a substance, but not the composition. All right, what does that mean? Well, that means that you can freeze water, but it's still H2O. You could take a block of salt and grind it into teeny tiny pieces, but it's still sodium chloride. It's not giving you a new substance. It's only changing what it looks like physically. Okay? The atoms and molecules that compose a substance do not change their identity during the physical change. Okay? And you guys are going to do a physical change lab here in a little while. When water boils, it changes its state from a liquid to a gas. So here's water that's a liquid, and here's water that's a gas. Still H2O molecules, but they're more spread out as a gas. The gas remains composed of water molecules, so this is considered a physical change. Changes that alter the composition of matter are called chemical changes. During a chemical change, atoms rearrange, transforming the original substances into different substances. So if you look at this picture, here we have iron atoms in a cubic form, and now they have picked up oxygen, and each iron is connected to oxygen atoms as well as other iron atoms, and it's created Fe2O3. So here's Fe, 1, 2, 3, and that guy must be the other Fe2, or the other iron. Okay, rusting of iron, dang it, is a chemical change. All right, so here's some examples. Solid carbon dioxide, which is dry ice, you know it as dry ice, becomes gaseous. That's called sublimation. It's changed from a solid to a gas. There are several substances that will do that. And if you look here at the microscopic view, we've still got a black center atom, which is the carbon, and two red ones, which are the oxygens. Solid sugar here. This is a sugar molecule, and they're all together. Each molecule is stacking up with the others, but once you've added it to water, there's the solid molecule, but notice the water molecules are now surrounding it. The water molecules have surrounded it. The sugar is still there. It's just been dissolved, which is a physical change. Here, we've got propane molecules, and we're going to add oxygen in. The oxygen comes in at this point, and they will change. The propane will change into carbon dioxide and water molecules. So that is a chemical change. You have a new substance that has formed. A chemical property and physical property. Physical property is a property of a substance that displays without changing its composition. Okay? Smell of gasoline, odor, taste, color, appearance, melting point, boiling point, density, all physical properties. Those all basically describe, you can use those to identify a chemical. Okay? Chemical property is a property that a substance displays only by changing its composition via a chemical change. We just talked about chemical changes. Flammability is a chemical property. Chemical properties include corrosiveness. In other words, how easily will it react with oxygen in the air, or if you mix it with an acid. Acidity, how the pH of a substance, and toxicity. Those are all chemical properties. And those are the notes. So now what you're going to do is you're going to get up and work in the lab, put all of your data in your lab notebook, and we'll go from there. Thank you very much.